So question आपसे कह रहा है describe the composition isotope thorium 230 decays by alpha particle emission. So ये एक thorium isotope है and it decays by doing what? By producing an alpha particle. तो अगर एक थोरियम था उसने अल्फा पार्टिकल प्रोड्यूस कर लिया तो भाई अल्फा पार्टिकल का मास नंबर 4 होता है, उसका प्रोटॉन नंबर 2 होता है. इट मींस दैट दिस आइसोटोप हैज लॉस्ट 4 इन मास एंड 2 इन प्रोटॉन नंबर. तो इट विल मेक ए न्यू एलिमेंट. जो भी वो नया पार्टिकल बनाएगा उसमें 2 प्रोटॉन नंबर कम होंगे और उसमें आपके पास 4 मास नंबर कम होगा. So it says describe the composition of alpha particle. Alpha particle की इस वक्त composition बतानी है. It's 1 mark and इसमें alpha particle सिर्फ nucleus होता है. It's not an atom. तो आप simply इसमें सिर्फ बताओगे it consists of 2 protons and 2 neutrons. Bus. Now state the name of the particle that is identical in composition to an alpha particle. आपको बताया कि alpha particle helium nucleus होता है. So alpha particle is simply helium nucleus. अच्छा जी. उसके बाद वो आपसे कह रहा है the alpha particle decay of thorium produces an isotope of radium. सही है. तो इसका मतलब है थोरियम बन गया रेडियम. रेडियम का जो मास नंबर होगा वो थोरियम के मुकाबले में इट विल बी 4 लेस, सो इट्स 226. एंड इसका प्रोटॉन नंबर जो है इट विल बी 2 लेस, दैट्स 88 नाउ. सो द क्वेश्चन सेज number of neutrons in a neutral atom of this isotope of radium. Neutral is very important. When it says neutral, it means protons and electrons are equal. So neutral atom, the number of neutrons बताने हैं आपको. So proton number 88 है. Neutron number it will be mass number, that's atomic number minus proton number. So that is 226 minus 88. Calculators out fast. Is that 138? जल्दी बताओ बेटे. I hope I'm clearly audible. मेरी आवाज आ रही है आपको?
Yes, sir.
Right. So proton is equals to neutrons. Sorry, proton is basically आपके पास 88 है. Mass में से इसको minus करोगे, you will get the number of neutrons. Now you need to know the number of electrons in the neutral. Neutral means protons are equals to neutrons. Protons are equal to electrons. So proton is 88. That means electrons will also be 88. So 88 electrons. Okay, half-life of thorium is 75,000 years. Radioactive sample contains 7.2 exponent 16 thorium atoms. Determine the time it takes for the number of thorium atoms to decrease to 9.0 exponent 15. So initially they have given the number as 7.2 exponent 16 and they are telling you how long will it take for this number to reduce to 9.0 exponent 15. So remember half-life. What is half-life? इसको मैं recall कर रहा हूँ जल्दी से. It's the time it takes for a radioactive isotope to reduce decay to half of its original, half of the initial value. वो टाइम जिसमें कोई रेडियोएक्टिव आइसोटोप, कोई रेडियोएक्टिव न्यूक्लियस अपने सैंपल का आधा हो जाता है. फॉर एग्जांपल देयर वर 2000 न्यूक्लियाई and it took 2 days to reduce to 1000. So what is the half life? 2 days, right? It takes 2 days for that sample to reduce to half. So it says determine the time taken for this sample not to reduce to half, but to reduce to 9.0 exponent 15. So if 7.2, अब आपने क्या करना, you need to break it down half every time. So how, what's the half of 7.2? It will break down into 3.6 exponent 6. Then that will reduce to 1.8 exponent, sorry, not 6, it's 16. 1.8 exponent is 16, right? And when you reduce that to half, it will get to 9.0 exponent 15, right? Or you can write it down like this as 0.9 exponent 16. It's the same thing. So tell me, you started from here. This was the original sample when this was not decayed, undecayed, and then it reduced to half. So how long it took to reduce to half? The half lifetime. It's 75,000 years it takes to reduce to half. Then it was 3.6 exponent 16. Then it reduced to half again, and it is now 1.8 exponent 16. How long it takes then? It takes another 75,000 years to reduce to that 1/4. And then it reduced further from 1.8 exponent 16 to 9.0 exponent 15. That's exactly half of the 1.8 value. So it will take another 75,000 years. So half-life is the time it takes for the nucleus, for the number of nuclei to reduce to half of its original value. Now look here. यहाँ पर you'll see this is when 7.2 reduced to half. The sample left is now 1/2. When it reduced to another half, so it left now is 1/4. When it reduced to another half, it the original sample left is now 1/8, right? So every time it halves, it's now halved how many times? Ek, do, teen. 3 times it has been halved. So every time it halves, it takes 75,000 years. So the total time would be 75,000 multiplied by 3, and that makes it what? Quickly, value batao.
Sir, 225,000.
2.25 exponent 5, right? Or 225,000 is true as well. ठीक है? अच्छा जी. Now, on figure 8.1, sketch the path of the gamma radiation in the electric field. So gamma radiations, they go undeviated, undeflected. Abhi discuss kiya, right? It will go straight through. Show us the electric field. यहाँ पर beam of gamma radiations that will also go undeviated, undeflected. Let it be electric or magnetic field. Gamma radiations will go straight through. Then it says, okay, ये हो गया. Next question, November 24, paper 2-1. The question is, the nuclide notation for the radioactive isotope of hydrogen is 3H1. This is the nuclide notation for hydrogen 3, that is tritium. Explain why hydrogen 3 cannot decay by the emission of alpha particles. Look, it's a very nice question. बहुत जबरदस्त. Alpha particle जब decay, when it's alpha particle decay, alpha particle has 2 protons and 4 mass number. So for something to decay by alpha emission, something has to decay by alpha emission, it has to have at least 2 protons and it has to have at least 4 mass number. If I look at hydrogen, hydrogen doesn't have mass number 4 or proton number 2. Hydrogen has a mass number of 3 and it's a proton number of 2. So it can never decay by alpha emission, right? It can never decay by alpha emission. So nucleus of hydrogen 3 contains nucleus of hydrogen 3 nucleus of hydrogen 3 contains only 3 nucleons. Only 3 nucleons. While alpha particle emission, there must be 4 nucleons. While alpha particle comprises 4 nucleons. 4 nucleons. All right. Now it says the hydrogen 3 अब alpha से नहीं हो रहा, तो it's emitting by beta to an isotope of different element. When it's beta decay, its mass number doesn't change. Its proton number alpha beta is -1, and zahir hai, left right side of the equation should be balanced. So if the hydrogen had a proton number of 1, now the new element formed must have a proton number of 2, one more than that, and the mass number would remain the same. So you need to check the left right side. Proton numbers on the right side, -1 plus 2 makes it what? Just 1. And protons on the left side, it's just 1 for hydrogen. Okay, now mass number on the left is what? 3. 0 plus 3 on the right side makes it 3 again. So the mass is conserved, the charge is conserved, the proton numbers stays the same. Now state the name of the element that's represented by Q. Every element is represented by its proton number. So 2 is a proton number for helium. So what is Q? Q is basically helium. So when hydrogen undergoes beta decay, it converts into helium. नया element बन जाता है helium. All right. Define half life. So जो चीजें हमने वहां पर अभी रिवाइज नहीं की थी, देखो क्वेश्चंस में रिवाइज हो रही हैं. What is half life? It's the time taken for number of atoms to half. It's the time taken for number of atoms or nucleons in the sample to halve. आधा होने में जो टाइम लगता है, that's called the half life. Sample of hydrogen 3 is placed on a laboratory bench next to a GM tube and counter. The count rate is recorded at the same time on 4 successive days. 1, 2, 3, 4 दिनों में same time पे count rate को record किया गया है. Why the count rate decreases and increases? देखो बेटा, जो radioactive decay का process है ना, it's a random and spontaneous process. So random होने की वजह से कभी रीडिंग ज्यादा आएगी, कभी कम आएगी. So लिख लो, radioactive decay is a random and spontaneous process. एक random और spontaneous process है. ठीक है. So इसलिए basically increase या decrease होने की वजह mainly random है. Spontaneous तो एक additional feature है इसका, लेकिन it's mainly due to the random nature of the radioactive decay that makes its reading to fluctuate. All right, another question. This is June 2024, paper 2-1. The table shows 4 different nuclei: thorium, protactinium, uranium. State which 2 nuclei have the same number of protons. Same number of protons.
Sir, uranium 235 and uranium 238.
That's it. Shabash. Uranium, uranium 235 and uranium 238. State which two nuclei have the same number of neutrons. So same number of neutrons किसके हैं भाई? Neutrons कैसे आएंगे? Mass number minus proton number. So 236 minus 90. What does it make? 236 minus 91. 235 minus 92. Tell me the numbers quickly. 235 minus 92. किसमें same number of protons आएंगे? Oh, sorry, neutrons. बताओ जल्दी से.
Sir, thorium 236 and uranium 238.
238.
Shabash. So thorium 236. Uranium 238. State which two nuclei have the same number of nucleons. Nucleons किसमें same है?
Thorium
Thorium 236 and protactinium 236.
Same number of nucleons, right? So thorium 236 and protactinium 236. Right. A teacher uses Geiger-Müller and counter to measure the background radiation in the laboratory. The counter records 20 counts per minute. The radioactive source is then placed in front of the tube and the counter records 420 counts per minute. State and explain what is meant by background radiation. So what is this? This is radiations present naturally in our surroundings. रोक सको तो रोक लो रेडिएशंस आई रे. ठीक है. सो रेडिएशंस हर वक्त मौजूद होंगी, इसको आप फिनिश नहीं कर सकते. कैलकुलेट द करेक्टेड काउंट रेट फ्रॉम द सोर्स. मेजर्ड काउंट रेट 420 आ रहा है एंड काउंटर ने रिकॉर्ड किया 20 काउंट्स पर मिनट. हाँ. सो व्हाट इज द करेक्टेड काउंट रेट? बैकग्राउंड को माइनस करोगे मेजर्ड में से, बैकग्राउंड को माइनस करोगे मेजर्ड में से. So it will be what? 400 counts. Righto?
Yes.
The radioactive source has a half-life of 45 minutes. Determine the reading on the counter 90 minutes later. So 45 minutes is one half-life. And they have given you a total of 90 minutes. That means they're allowing you for the substance to decay 2 times. Yes or no? ऐसा ही है. Yes or no? बताओ.
Yes.
So what was the count, the measured count rate? It was 420, right? Measured count rate was 420. So that means the actual count for the substance was what? It was 400. You allowed it to decay for 90 minutes. It will decay and it will come 200 in 45 minutes. Then it will decay again. ये तो 45 minutes में हो गया. एक एक्टिविटी फिर से होगी. Another 45 minutes. It will reduce to half once again. And this will be 45 minutes again. So now this is actually the count rate. This is actually the count rate after 90 minutes. But there's a twist. The counter doesn't read this alone. It reads the background 20 as well. So what will be the measured count rate? Come on. Decay हो गया.
100.
Come again.
100.
100 तो आ गया ना.
जी.
100 is actually the count rate, right? 100 is the count rate. But will your detector read 100?
2.
Then what? More or less?
More.
How much?
105.
20, right?
Sir, can't you do this that before decaying आप पहले से ही 420 कर दो?
Okay, so you want me to make it decay from 420 to 210 and then to
105.
right? Okay.
Yes.
Why should this be wrong? You tell me. थोड़ा सा दिमाग लगा के बताओ. Why should this be wrong?
Because background radiation cannot be halved.
Wow. Simple. Background
Okay.
radiations तो उतनी ही रहेंगी, वो तो हाफ नहीं होंगी ना. चेंज नहीं
जी.
आएगा. चेंज आएगा तो जो सब्सटेंस है उसकी रीडिंग में चेंज आएगा. सो
Okay.
बैकग्राउंड रीडिंग से पाक करके रीडिंग लो, सही है, और उसको डिके करवाओ. सो 120 का suggest why your answer is only an estimate. ये आंसर जो हमने निकाला ये सिर्फ एस्टिमेट है. Why it's not the exact?
Because there could be more background radiation.
It's that like that as well. And secondly, the nature of decay is random, now.
Yeah, right.
Random nature of decay. You don't know whether it reads 120 or 125 or 115. Right? Okay, figure 7.1 shows different uses of three different types of radiations. Draw a line on figure 7.1 from each use of radiation to the type of radiation used. One line has been drawn for you. Each type of radiation can be used once, more than once, or not at all. So, household fire alarm, alpha particles use करेंगे. Irradiating food to kill bacteria, bacteria को kill करने के लिए एक ही हमारे पास चीज है, that's gamma. Sterilizing equipment, अल्फा और बीटा तो यूज नहीं हो सकता, गामा ही यूज होगा बेटे. या फिर अल्ट्रावायलेट होता तो वो यूज हो सकता था, या एक्सरेज यूज हो सकता था. मेजरिंग पेपर थिकनेस, सिंपली बीटा पार्टिकल. अल्फा इसमें क्यों यूज नहीं कर सकते? अल्फा तो पेपर से ब्लॉक हो जाता है, थिकनेस कैसे मेजर करके देगा? राइट. June 24, paper 2-2. So the fourth question. Alpha particles are sometimes emitted from nuclei of radioactive elements. These emissions both random and spontaneous. Describe what is meant by spontaneous emission. Spontaneous का मतलब ये होता है the decay is unaffected by environmental conditions. आंधी हो, तूफान हो, टेम्परेचर कुछ भी हो, प्रेशर कुछ भी हो, वॉल्यूम कुछ भी हो, आपके पास इन्वायरमेंटल कंडीशंस डिके को नहीं रोक सकती. देखिए एक स्पॉन्टेनियस एमिशन है, वो हमेशा होकर रहेगा. सही है, डिके को कोई नहीं रोक सकता. सो व्हाट इज मेंट बाय स्पॉन्टेनियस एमिशन? Spontaneous means spontaneous means decay is not affected. Decay is not affected by environmental conditions. By environmental conditions. ठीक है, environmental conditions इसको affect नहीं करती, जैसे कि temperature हो गया या फिर pressure हो गया. So it's unaffected. जो decay होना है वो होके रहेगा. Composition of alpha particle फिर बताओ. It is a helium nucleus. क्या है भाई? 2 एक बार सिर्फ प्रोटॉन और न्यूट्रॉन नंबर बता देते, it's enough. But 2 marks. It is a helium nucleus. Helium nucleus. It consists of 2 protons and 2 neutrons. It consists of 2 neutrons and 2 protons. Okay. Alpha particles, wow. Alpha particles are detected using the tracks shown in a cloud chamber or by the sparks produced in a spark counter. ये क्वेश्चन बहुत टाइम बाद आया था 2024 में, और लोग इसको बहुत रेयरली पढ़ा करते थे, तो इट वाज अ सरप्राइज कि अचानक से क्वेश्चन आ गया था. So you need to describe the structure of either a cloud chamber or a spark counter, and you need to include a labeled diagram of the apparatus. तो क्या बताया था आपको? सबसे पहले spark counter का बता देते हैं. It was just a wire mesh. One end was connected to a high voltage 4000 volts. That was, the other end was basically a thin wire which was connected to the negative terminal, and this is the wire gauze. Now you need to describe the structure. अब structure के लिए लिखना भी है. क्या लिखें structure के लिए? So basically a high voltage is applied between wire and the gauze. Wire जो है और ये जो gauze है, इसके बीच में आप एक high voltage जैसे कि 4000 volts, a high voltage that is 4000 volts is applied between wire and the gauze. Which should be wire and the gauze. Until sparks are observed, जब तक sparks नहीं दिखते. ठीक है? So ये हो गया spark counter. इसके अलावा cloud chamber भी होगा, तो कोई एक आपने बताना है. Now it says describe how the emission of alpha particles is shown as random in the apparatus you described. ये जो मैंने apparatus describe किया, इसमें alpha particles की जो emission है वो random है. कैसे पता चल रहा है? देखो, जो 2 sparks होंगी, बाज़ औक़ात sparks जल्दी जल्दी हो रही होंगी, बाज़ औक़ात देर से हो रही होंगी, बाज़ औक़ात हो ही नहीं रही होंगी, बाज़ औक़ात बहुत ज़्यादा sparks होंगी, right? So time between 2 spark is different for every spark. या फिर the number of sparks in a given time is different. पहले आपने 1 मिनट तक sparks को count करते रहे, that was let's say 10. दोबारा आपने count किया, आया 12. फिर आपने count किया 9 आया, फिर count किया 15 आया, right? So basically the number of sparks in a given time is different. That will show कि alpha emission एक random process है. Number of sparks for a given time is different. बात समझ आ रही है बेटे?
Yes.
अच्छा, और अगर मेरे पास क्लाउड चैम्बर बनाता मैं, तो क्लाउड चैम्बर कैसे बनाता? बहुत सिंपली बेटा, चैम्बर का मतलब है चैम्बर ही बनाना है आपने, एक डब्बा बना दिया आपने यूं, दिस इज द चैम्बर नाउ. So you must be placing dry ice at the bottom. Dry ice. Remember, the examiner doesn't test your Picasso art skills. वो सिर्फ आपके कॉन्सेप्ट को चेक करता है. यहाँ पर फेल्ट लगाया हुआ है आपने, फेल्ट इन एल्कोहल. सही है, फेल्ट इन एल्कोहल, एल्कोहल में सोख करके लगा दिया आपने. यहाँ पर आपने रेडियो एक्टिव सोर्स रखा है, सोर्स रखा है. ये ऊपर जो है इसका ट्रांसपेरेंट लिड है ये वाला. दिस इज द ट्रांसपेरेंट लिड. एंड यहाँ से यू हैव प्लेस्ड अ लाइट सोर्स, यू हैव प्लेस्ड अ लाइट सोर्स. ठीक है, जो यहाँ से इल्यूमिनेट कर रही है इसको. दैट्स द स्ट्रक्चर. खत्म, इसका मार्क मिल जाएगा. नाउ द क्वेश्चन इज हाउ द emission of alpha particles is shown as random in the cloud chamber. So भाई क्लाउड चैम्बर में ट्रैक्स बनती हैं. क्या बनती है? ट्रैक्स बनती हैं. तो ये जो ट्रैक्स बन रही होंगी, all the tracks will have different time. कभी दो ट्रैक्स के बीच जल्दी जल्दी बन रही, कभी ट्रैक्स देर से बन रही, कभी बनी नहीं रही. नंबर ऑफ ट्रैक्स इन अ गिवन टाइम इज डिफरेंट. आपने नोट करना शुरू किया, पहले 1 मिनट में आपको 12 ट्रैक्स नजर आई, फिर आपको 10 नजर आ गई, फिर अचानक से 15 हो गई, फिर 11 हो गई. सो नंबर ऑफ ट्रैक्स, ये तो था स्पार्क के लिए ना, स्पार्क काउंटर, स्पार्क काउंटर के लिए ये था. अगर क्लाउड चैम्बर हो, क्लाउड चैम्बर, उसके लिए क्या करोगे बेटा? नंबर ऑफ ट्रैक्स, number of tracks in a given time, in a given time is different. Are you getting my point?
Yes, sir.
Yes.
Now the radioactive source produces 120 tracks in 1 minute in a cloud chamber. 6 hours later the same source produces 15 tracks in 1 minute. Without the source present, no tracks are produced. So कोई reading नहीं आ रही without the source. Calculate the half-life. So the tracks are reduced from 120 to 15. So 120 को अगर आप reduce करते जाओगे, हाफ करोगे, हर बार इसको हाफ करोगे. 60 का half 30 का half 15. So the tracks formed will be now 15 in 1 minute. Now how many times has it decayed? पहली बार ये decay हुआ, फिर दूसरी बार decay हो गया, फिर तीसरी बार decay हो गया, right? Now what is the half-life? 6 hours later the same source, sorry, not the half-life, we have to find the half-life. So for they have 3 activities, 3 बार half हुआ, ये activity 3 बार repeat हुई है. How many times? The activity has repeated 3 times, right? So 3 बार half हुआ है, 3 बार ये activity repeat हुई है. And how long does it take for the activity to be done 3 times? It takes 6 hours for 3 activities. Tell me, how long does it take for one activity? 2 hours. So what is the half-life? 2 hours.
2 hours.
Got it? Any problem, any confusion?
No.
Right. So we have done around 4 questions on radioactivity, on nuclear physics. I would want you to do as more as possible. I'll also be sending you that Google form wala MCQ ka link for this. Do that and then let me know if you have any problem. So in the meanwhile, also tell me, would you want me to do more questions on nuclear in the next class, or would you want me to move to space physics?